In this video, we'll talk about how we can work with time series data. The fundamental building block of time series data are timestamps, and they represent one moment in time down to the precision of a nanosecond. We can create timestamps using the toDatetime function, and to that we pass our time as a string, and for that there are different formats. So here we first specify the year, then the month, and then the day, all separated by this dash. And if we run that, then we get a timestamp referring to the year 2022, then the month is June, the 9th day, and we also specify hours, minutes, and seconds. And if these smaller time units down to the nanosecond are not specified, they are set equal to 0. Here we can see another format, so we have the 9th of June in also the year 2022. That gives us the same timestamp. Here we have another format. What's important to note is that if we use the dot to separate our days, month, and year, then it assumes the American date format. So month comes first, then the day, and then the year. So this will not give us the 6th of September, but instead also the 9th of June. And so to fix that, we can pass the day first argument, and we set that equal to true, and then our string is read in the normal time format. We can also add hours and minutes to our string, so now that part in the timestamp is not 0 anymore, and we can do that up to the precision of a nanosecond. And once we have initialized our timestamp, we can access the different time units. So we can use the .year to get the year of our timestamp, .month, day, second, microsecond, and nanosecond. A very important feature of timestamps is that they can be compared. So we can use the normal, smaller, or greater sign to compare to timestamps. If we now want to build a time series from these timestamps, then we can pass, for example, a series of these time strings to the toDatetime function. And that gives us then a series with the type datetime64. And what we notice is that the none got converted to NAT. And this is the time equivalent for not a number. And here it means not a time. We can also pass a list to the toDatetime function. This will not give us a series object, but an index object. And so we can use that to index our data frames based on time. We can also use timestamps to format our strings. So we can call on our timestamp the string format time function and pass to that a string that contains these formatting placeholders. And with this link here, you can look up what all the letters stand for. If we run that, we see that the A takes the weekday, so today is a Thursday, and B takes the month. We can also specify the format of how we want to read time from the strings that we pass to the toDatetime function. So here we have the normal format of day, month, and year, then hour and minutes. And so 12 corresponds to day and will be put last or next to our month. And if we were to switch that, so we switch month and day, then month and day are also switched in our timestamp. Okay, next up, the datetime index. And that's a very important use case of timestamps, so we can use them to index our data. And to create a datetime index, we can pass the times as strings to the datetime index function. And in here we have a normal series containing some strings, and we can pass to that our index, so our datetime index, and that gives us then a schedule where we have timestamps for indices. As we saw before, this also works with the toDatetime function, but using the datetime index is a bit more explicit. And then once we have our series that is indexed by timestamps, we can use these timestamps to do, for example, slicing. A small note on the values that do not relate to time. So for example, if we try creating a datetime index from this correct formatted string and then this random string, it throws us a type error, which makes sense because that cannot be converted to a timestamp. And so what we can do is we can coerce these errors. So we pass the string coerce to the errors argument, and now the ASD will be converted to a not a time value. And we can check which values are not time values by using the isNull function. We can also use the isNA function, and they are actually equivalent. So they're actually both referring to the same function.